Okay, so hello everyone. Myself Javardhan Shukla. I am a contributor to the Liquid Galaxy project and an avid open source enthusiast. So I'm very excited to bring about this presentation on building immersive experiences with hand gesture recognition and Liquid Galaxy. So this presentation is going to talk about how we can build a gesture recognition system using hand gestures and control the Liquid Galaxy like using them. So we're going to talk a bit about the TensorFlow, the Media Pipe, the Google ML Kit, and other packages that are there, which help us to do the gesture recognition thing, especially in Flutter. Let's dive into this topic straight away. I'm sure everybody might have used the hand gesture recognition at least once or twice in their life in various other applications. So we know how the typical gesture recognition system works from a development point of view. The main challenges associated with traditional inputs is that they limit any intuitive interaction with the user. The level of flexibility and ease is a very basically atypical when we use the standard input methods like keyboard and mice. So the solution is to use hand gesture recognition revolutionize the Liquid Galaxy experiences. So how these things work, we can see this typical flow chart right here. First of all, there is a camera input. The camera input can be given using any standard package in Flutter. For instance, a camera is one of these packages. It basically provides containers as well as limited inputs of images. So we can pass this input into the image processing. The image processing is done using the TF Lite TensorFlow package. We might have to import the basically embed the model in our application. So we're going to see how we are able to do that. Then we are going to do the hand detection. This is done by the model itself. Then finally it outputs the gesture that might or might not be might be present in our image. Finally, we have to map that specific gesture. This part is basically a bit manual that we had to do that ourselves. And finally, as soon as gesture is detected and we have mapped that, so we have to execute the specific echo command via SSH to the Liquid Galaxy in order to allow the Liquid Galaxy to do that specific thing. So this is how the whole thing works. Next thing our discussion is about TF Lite plugin. The TF Lite plugin is developed by TensorFlow. It's a very lightweight library for deploying ML models on mobile or embedded devices. It has offline interference, obviously. So we're gonna see how this thing works. The architecture of this TF Lite model is very similar to the original TensorFlow model itself. Only that there is this converter code that basically converts our trained TensorFlow model into our TensorFlow.lite.tflite model. So this is the .tflite model that we have to store it in our assets folder when it comes to our Flutter application, and then we might use it using the requisite functions of the same model, so we can use them for our gesture recognition purpose. We might also be able to use it on embedded devices, but that is out of scope for now. We're gonna see the package that I'm referring to. It is this package, the TF-Lite slash Flutter. It's a very recent package. It is published just 5 months ago from the TensorFlow organization itself. So it's one of the most popular packages. Obviously, you can see the analytics right here. The key features of this package is that the flexibility that is provided. It has provided so we can use any TF-Lite model along with this package. The most important thing here is that the acceleration using multi-threading. So multi-threading feature basically allows this package to not to depend on a single thread, which basically can make our application very resource intensive. So using multi-threading, this basically um, obfuscates that possibility. we might not be working solely on a single thread, which makes our application much more easier and convincing to use from a development standpoint of view. So it has similar structure as TensorFlow Lite Java API. So one of the most important things to note down while using this package is that we might have to keep our Java version same, basically compatible with the TF Lite Flutter package. Otherwise, it might lead to any kind of issues during the development phase itself. So this is one of the challenges. Obviously, the package would not work if there is no compatible Java version. So this is something which we have to keep into account. So next thing is the interface speeds. The speeds close to native Android apps built using Java API. So there's no problem with inference. Then we can run inference models in different isolates to prevent jank in the UI thread. So now we're gonna see how we are setting up this thing. So first of all, we have to import the TF Lite slash Flutter in our requisite screens, or basically our classes, our stateful and stateless models. So basically, this is the function of dot from asset, which allows us to pick up our model from the assets folder, the TF Lite model basically. So now what we're going to do is that we have to run this model for single or multiple inputs. So for single input, what we are going to be dealing with is landmarks. So what landmarks are? Landmarks are basically a 2D arrays. They are numpy arrays, which we can understand landmarks using this way. So assume that your body, in your body there are various different organs. Each organ or each body external body feature is given a specific number, just for identification purpose. So for instance, your mouth is given number 1, your eyes are given number 2, your noses are given number 3, and so on and so forth. So what they have done is that in each image they are detecting what all numbers they are basically getting, and then they are basically giving out the probability in terms of decimals of that number. So this is how the landmarks are. They are 2D arrays. They are of the shape basically 1 comma n is the number of landmarks that the model is able to detect. So output tensor is something that we have to specify, because we might have to get specific landmarks from the user, and then we would be able to say that this particular gesture is there. For instance, if somebody is giving a hand up gesture, then the whole hand, palm, and the feet of the indexes of the fingers, and our basically other body organ, other body features have to be there in the image, and then it would compare that with the output, and then would say if our inference is true or basically not. This is kind of a probabilistic thing, but it works obviously very streamlined. We can also do this for multiple inputs as well by using lists. So this is the code that it gives. Finally, we have to close the interpreter. This is a very important thing. We might do it on destroy in a specific Flutter widget, so that it automatically closes the interpreter. This is something which you have to do with the media pipe and Google MLKit models as well. So we can see that the interpreter is loaded from assets. This is an async obviously, so the function that function calling needs to be totally asynchronous. Then there's this isolate interpreter variable that basically creates our instance of the isolate interpreter. We have to specify the address, which we can do by dot address command. Then we have to run this in our input and output, and we have if we have multiple inputs, then we have to use this function for multiple inputs. This is how the whole TF Lite Flutter package works. So back into our presentation, we can see that we have already discussed about the model architecture, so let's move further ahead. So the next thing to talk about is the models which are compatible with the TF Lite. There are vision models, NLP models, and the AR/VR models. So we there can be other models as well, but these are one of the most important ones, and they are obviously related to the Liquid Galaxy project in one way or the other. So we're going to talk about them. Vision models include segmentation models, classification models, and object detection models. Most famous object detection models are YOLO V5 and MobileNet. We have seen the usage in a lot of applications nowadays. Classification models include mobile net, and segmentation models include our deep lab or recently included the Meta's the segment anything models. The segment anything model is a very versatile model, and I would highly recommend anybody to check it out at least once. The segmentation capability of that model are very robust, and it can basically segment anything in the video itself. So for real-time segmentation, that is something which is very favorable nowadays. Next thing is our natural language processing, the text-to-speech and language translation, and our AR/VR things. AR/VR things are object detection using Objectron, style transfer, hand tracking using media pipe, and gesture classification. We're going to talk about the hand tracking using media pipe in the later. So we know about the gesture recognition. It identifies and classifies hand gestures using ML for intuitive interaction with systems like Liquid Galaxy. How it works is that we have to first of all provide a live camera feed to the user. Then the camera feed basically gives us the camera input in the form of input asset image, which we have to give to the hand tracking model. Our hand tracking model detects any kind of basically coordinates of the any kind of numeric 2D input array, and then this basically goes to a classification to compare what kind of gesture is there. If any gesture is identified, then we have to map that to a specific action. For instance, there are three different actions are provided in this flowchart. We can basically have n number of actions. So now we are going to discuss about what all how basically things works. So this is the media pipe page for hand. It's called as the media pipe hands. This is a very famous solution for hand detection provided by the media pipe. So media pipe first of all is a very strong library for these kind of things. I would highly recommend this library because it is much more accurate, enhances the accuracy of TensorFlow models by a huge degree. So this is how it works. The media pipe basically creates connects all of our landmarks by using these tree kind of structure. The no basically it starts with the base tree and connects all the index of finger indexes just like the nodes of a specific tree. So um, the new numbers here are basically the landmarks that we talked about. So if we go down here in the page, we can see that there are lots of numbers discussed here. So the 0 specifies our wrist, 1 specifies our thumb bottom point, 4 is our thumb tip, 8, 12, 16, 20 are our tips of other fingers, and so on and so forth. So basically the media pipe model detects these indexes in our image. We can see that it is detecting these indexes using these red points. So when they are detected, basically tells us about what kind of shape it gets in, and then because of this shape feature we are able to detect our hand models. So yeah, so we can check this out the web page once. It also provides this Python code for running this whole model in the things like Google Colab or maybe in Jupyter as necessary. So we can use this hand detection model right there itself. So the next thing is to focus on is our applications of these things in our Liquid Galaxy. So we can use them for swipe gestures in 3D map navigation. We can do basically gestures like these, and Liquid Galaxy would respond accordingly. So the other things include pinch to zoom, the point to select and manipulate objects, and these kind of things are very ideal for boardroom discussions where we might be providing our inputs intuitively, which is also very nice for presentation point of view, and also it eases the basically inputs as well, because the presenter would not be basically fetching their typical input devices during the presentation. So now we have to compare the MediaPipe versus TensorFlow Lite. We know that the MediaPipe is much more versatile compared to the TF Lite models, but they have specific role requirements, basic and usages as well. So the TensorFlow integration is based on models, so it requires developers to manage input-output processing by themselves. The function it basically allows the conversion and deployment of custom models on device interface, and it deploys ML models on edge devices. So whereas when we talk about media pipe, it provides pre-built pipelines for real-time media processing. It offers ready-to-use solutions for tasks like hand detection and pose estimation, and for integration purpose, it simplifies ML integration with standardized interfaces. So we can use TensorFlow Lite when developing custom trained models with specific requirements. If we have any selectable requirements, then we have modify the input and output of the TF-Lite model accordingly as per our convenience. And we can use media pipe if we are seeking ready-made optimized pipelines for common media processing tasks. These are a bit easier to be used, and they are also used in various other packages as well. So next thing to talk about is our Google ML Kit. This is the logo of the Google ML Kit. It basically brings Google's machine learning expertise to mobile developers in a powerful and easy to use package way. ML Kit pose detection is a very famous package from the ML Kit. It identifies the human body poses in real time from images or video streams by using media pipes models. So basically it is also very similar to the medium pipe model, but that this one has landmarks for the whole body, and not just the hand, so it identifies the each part of the body by using these landmarks. So if we go into the pub.dev page of this library, we can see that this is the thing that we are going to use in our application. It's a basically very versatile package. It's provided by Flutter ML itself, so it's a Google package. So basically it allows the communication between the client and the host by using channels. So minimum SDK version should be 21, target SDK version should be 33, and compile SDK version should be 34. So we can see it's a basically a very recent package. The compile SDK versions are very much updated ones. So the thing here is to basically pass an input image. We have to create an instance of this input image, and then basically assign this input image variable with our real input image, which we're going to take from a camera or other whatever system we have designed. So most important thing here is to focus on the options. We have to provide options along with our pose detector, and the pose detector basically instance in a post director instance, we have to pass these options as a parameter. So we have to basically create class instances of these, and then we have to, for processing the image, we have to give basically an asynchronous time lapse for the pose detector to process the image. It returns all the poses that are there in a particular image, and for each pose we can segregate its landmark. We know that these are 2D arrays of shape 2, so there is an x and y. So for each an x and y, it specifies a type, the final x and final y. Now we can set up any kind of we can say model mapping inside this folder itself, inside this inside this for loop itself. So we can map these here, and then we can use them in our application. Finally, we have to close this on destroy, so that it doesn't use any kind of memory lag in our application. So this is a typical overview of the Google ML Kit post detection. So back to our presentation, we can see that integration steps look like this. First of all, we have to specify the pose detection in our YAML file. Then we have to use the camera package to capture live images. Then we can convert the images into input image format for processing. This can be done using camera package itself or using the ML Flutter package. So then we have to create an instance of the pose detector, as we have already seen in our plugin page. We are creating the pose detector instance, and we are passing the options as a parameter to the pose detector. So we can pass the input image to the process image function of the pose director. So we can use pose director dot process image, and we can pass the input image directly into there. It analyzes the landmarks and gives us the required hand gestures to be done. This is a sample code for that. This is the pose detector. We have basically give the options right here. The input image is done from the file path. We can also do it dynamically, and in the real time we are going to do it dynamically, obviously. So we have to basically give a poses, which is a list, obviously. So it processes the image and gives us the poses, so it's very easy to use. We can define all of our gesture mapping in between these two for loops. So and then we can do all the ssh commands directly here. So now develop a basic integration for ml kit and flutter. I've already created this application. So I'm gonna this is my application. First of all, I would go into the pubspec.yml. So we can see that in the pubspec.yml I have basically added a bunch of dependencies. Prominent one of them being Google MLKit post selection and camera. So first of all, we have to include all these dependencies in our application. Then we're going to go to pose view.dart. So here we have basically specify what poses are there. So we can see that import is done. Finally, we can do define a number of global variables. One of them being the pose director for this class. Pose director takes us the specified default options. These are bunch of control variables that we also have to create. These are not so important. Custom paint is basically an overlay in the camera itself for detecting the poses. So then there is this dispose function, which basically closes the pose director, obviously on screen destroy. So we can see that we are passing the process image on the on image function in the detector view, and basically it takes the initial camera lens direction, the camera lens direction value, and so on and so forth. So first of all, in this process image function, it has to be asynchronous, and then we have to give the process image in this function itself, and it would return a metadata. That metadata is something which is helpful for us. We can do a pose painter and we can find out what poses are there, and we can specify them to the user. So yeah, so this is an overview of how we can use this thing. So now we are going to move on. We are going to talk about bit about the landmarks now. So these are the landmarks that are there in the ML kit. There are 33 skeletal points, including hands and feet. Eyes are there, obviously. We can see right eye, we can see the left eye, and so on and so forth. We can see in the hand part there is this 19 number called as the left index, 17 number is called as the left pinky finger, and so on and so forth. So these are 33 skeletal points that are defined in the ML kit. So finally, we're going to go into the demo part. First of all, I would show you the difference between the media pipe as well as the typical ML, typical TF Lite model. So this is going to open my collab notebook. I have already created one and utilize the functions. So this is the same collab notebook as here. So this is already connected, so we can use this one, and we can see that I have already imported my hand landmark.tflite file. So this is something which we are going to use. So first of all, we have to capture the image from the webcam. This is for simple JavaScript code, and then we are going to pre-process the image, uh, just normalizing it, resizing it a bit into this 224 to 224 dimensions. Then we are going to find out the gestures accordingly in the land by and identifying the landmarks. We can see that what landmarks we are getting here. The 16 number is basically our 17th pointer. So we have already seen what pointers were there. So 17 pointer is our fingertip. This we have taken from the MLKit library itself, and then we can define the various gestures. So finally, we can run the TFLite interference. So it works this way. So Now, this was the typical code for the TF Lite. Next, we can use the media pipe. So we can install, basically import all these and use the same code. But this time we have, what we have done is that we have also used the media pipe, the solution.hands package that we have discussed previously. And then we have used this to find out all the gestures. This is the code for recognizing gestures, the thumb tips, wrist, index, page, and so on and so forth. So this thing finds out how many fingers up, fingers down, thumbs, and so on are there. And accordingly, if there are five fingers up, then we can say it's an open hand. If the zero fingers are there, then it's a fist. And the two fingers are there and not more than two, then it's a peace sign along with not no any thumb. So these are the other gestures that are there. So we can see that this is an input that I provided. You can see how well it connects the media pipe thing. So it obviously is much more versatile than the typical ML kit response. So yeah, I have added this in my Google, on my repository, so one can check it out from there. So thank.
So now I would present to you the demonstration of an application which I created in Flutter. So let's jump into my Android Studio directly. So this is the whole code for that application. So I'm gonna start with the main.dart. Before that, this is my assets folder, and you can see that there is this hand landmark.tflite file present in my assets folder, which I would use for my hand or gesture detection purpose. So first of all, let's go to the pubspec.yaml. You will see that the Google MLKit code selection along with camera and other plugins are already instantiated right here. So there are various modules that I have built in the lib. So you can see that there is this camera module. This is the main module. So basically it contains this camera view. You can see that the camera view contains MLKit commands, which is which comes along with the MLKit, along with the camera widget. So basically, what it does is that it opens this camera view right along the screen. So it basically takes on this bunch of parameters right here. Um, so all these parameters would be basically default values like the zoom level, minimum available zoom, max available zoom, and so on and so forth. So we can alter this as per our requirements. So next thing is basically creating the top layout. So there is a app bar containing these two buttons, icon buttons specifically for flipping the camera and one for moving to the photo library. So this is basically what we will be I will be demonstrating right now because the camera basically is it works a bit differently in the virtual devices that it uses the webcam, and the webcam doesn't really focuses on the current posture. So there's a bit of a posture difference when it comes to using a real device versus using an emulator. So I'm gonna demonstrate using the photo library, which is gonna open the default camera of the device. So this is how everything is set up. Basically I will upload the whole code in the GitHub, so one can check out from there. Just for a list point of view, this is the page view, which is the most important file. So we can see that I have defined a bunch of codes right here. So there is above that is a code for detecting gesture. So this is the string function right here. We can define what kind of posture basically the user is getting. So for instance, if the right hand is up and the left hand is up, then we can say that the zoom in should be activated. If the right hand is down and the left hand is down, then zoom out should be activated. For zoom in, I mean this particular gesture, and for zoom out, I mean this gesture. All these gestures are defined in the help, obviously. So if the right hand alone is up, then we have to move north. If left hand alone is up, then we have to move south. If the left hand is up in this way, then we have to move east. In this way, then we have to move west. So these are the gestures that I have instantiated for now. These are the codes which are basically dealing with the landmarks. So now the main thing is right here. We have basically designed this switch case to basically move north, move south, and so on and so forth. Finally, the SSH basically takes us to the requisite position. So this is how the whole code is set up. So now I will try to give you a demonstration of the our device. So you can see right on the right side, this here is the application that I have created. So first of all, I will go to the settings. So we can see that the settings are very typical for different Galaxy controlling devices. We have IP address, port number, master ID, master password, and number of screens. So we, as soon as when enters that, this basically connects to the LG rail. Along with them, there are buttons like relaunching, reboot, and shutting down LG. So my whole LG setup is right here in my computer. I have already opened up three VMs and the LG is open here. So once I click on disconnect, it disconnects to the LG, and once I click on connect, it automatically connects to the LG. So yeah, you can see as soon as the connection is done, it automatically moves back and takes us to India. Yeah, this is something which goes on by default. So now once that happens, we basically recognize that the connection is done. So now I want to demonstrate how the gesture control works. So you can see it's opening a default camera view, but due to the basically virtual device being used here, it is showing me along the very right edge. So this is here. This is me. Hello. Yeah. So what I would do is that I will open this gallery view and I would click on the camera. So it will basically do the same thing. Here it's opening the default camera of the screen. So I will perform the gesture for moving to the north. So for that I have to open basically my right hand up. So this is my screen. I will click on this image and yeah. So see, the LG is responding by moving north. Similarly, I will click on the camera again, and this time I will try to move to south direction. Yeah. So see, it's now moving south. So this is how the whole thing works. Hopefully, if I would like zoom into it a bit and let's say move to north again and try to go to the camera. Moving the camera a bit just to basically focus on my gesture. And here we go. So you can see it is basically detecting south and it moves towards the south of the globe. So this is how all the gestures are set up. We can set up multiple gestures here, not just these. For instance, we can see that we can set out zoom in, zoom out, other gestures as per our requirement. I have not set up these right now, so we can set up multiple other gestures as per our usage. So now I will try to demonstrate what all gestures are there. So for that, we will move to the help screen and use gesture controls. We see these are the gestures that are there. For moving north, we tried this. For moving south, we tried this. For direction control east, we try this. For direction west, we try this. For zoom controls, we try this and this. So this this application is created by taking another application as a reference standard, which is uploaded to the Liquid Galaxy. It is created by contributor Sulanio during 2023. So if you search Liquid Galaxy gesture controller, this would come up right. Yeah, so this is the application. I have taken this application into account during the I'm sorry, I think this is not the right application. Just a moment. Yeah. So this is the application right here. This is created by Sudhanyo during the Liquid Galaxy 2023 for Google Summer of Code. So I've taken more inspiration and the core understanding from this, so one can reference this application as well. It is a very versatile application, but this is basically for tablet display. The application that I have created is for a mobile size display. So I would upload the whole source code of this application as well, just for someone to see. So yeah, this is it. Hopefully, you will like my video, and thank you so much.